Hi guys, welcome to this video. This is going to be really helpful for you if you're looking for the final exam prep of your AP Precalculus, because this has all the 3 units. You can download the worksheets from the link in the description. There's also timestamp in the video so that you can easily go to the unit that you feel you struggle the most with. And if you need private tutoring, feel free to reach out. Okay, all right. Over here we are given that there's a, okay, so this is applicable for questions 6 to 10. So we are given a function and they are asking that but from 0 to 9, how many inflection points does the function have? Recall that inflection points are the points where the function changes the concavity, or in other words, it changes from frowning to smiling or vice versa. So it feels like this is one inflection point because this is a frowning face and this is a smiling face. Then this is another inflection point because this is smiling and this is frowning. And then probably here there is another inflection point because this is frowning and this is smiling. So I'm going to mark option C. Which of the following statements about f is correct? From 7 to 9 they are asking. So from 7 to 9, I think this is our curve. They are asking if it is positive or negative, or if it is increasing or decreasing. Clearly the function is negative because it is below the x-axis, right? So the function's value is definitely negative. So it's below the x-axis, so that's for sure. And it is increasing, of course, because if I am going to the right side of the, if I'm approaching to the right, the function is climbing. So it is negative and increasing. That's what I'm going to mark, which is going to be option C. Okay, then they are asking between 1 to 3, what's happening? So from 1 to 3, again, the function is right over here. And from 1 to 3, I'm going to say that the function is definitely decreasing. So it has to be either C or D. And they're asking the rate as well, which is another way of asking the concavity. Clearly, between 1 to 3, it is smiling in nature, and smiling function is increasing rate. So I'm going to mark option C. Then they're asking from 0 to 1 what's happening. So from 0 to 1, there is the function, and clearly from 0 to 1, the function is concave. Let's see what they're asking. They're asking, okay, they're asking increasing, decreasing. So obviously the function is decreasing. And then they're asking whether the function is concave up or down. So definitely the function is concave down here because it is frowning in nature. So decreasing and concave down, that's the correct option, which is D. And then they are asking between 5 to 7. So 5 to 7, let's go over here. 5 to 7, the function is decreasing and concave up, correct? Between 5 to 7, I hope you're able to see. 5 to 7, decreasing and concave up. They are asking 5 to 7, the rate of change. Okay, now they are asking about the rate of change. We already know that the function is decreasing and concave up. And whenever the function is decreasing, ROC is negative. So ROC is positive? Nope. ROC is negative. And whenever it is concave up, ROC is increasing. So it has to be option C. I hope it makes sense. Usually, I have a couple of videos on the ROC, increasing, decreasing, positive, negative. Feel free to check that out in the playlist. I hope this is clear. Okay. All right, over here we are given that again there is a function and we need to figure out which of the following is correct. Clearly the function is increasing here because the function is climbing, and it is concave down. So concave down means decreasing rate. So increasing at a decreasing rate looks like option B. Likewise over here the function is obviously decreasing because the function is declining. And the function is concave down, so decreasing at a decreasing rate because it is concave down, which looks like option D. Over here, the function is again decreasing and it is concave up, so decreasing at an increasing rate, which is option C. And the next one is clearly the function is climbing, so increasing, and the function is smiling as well. So increasing and increasing rate, which looks like option A. Okay. Over here, the options are a little different, right? So they're asking the function is definitely increasing or decreasing. So function is increasing, but function, okay, this is actually pretty straightforward. They are just asking whether the function is concave up or down. So obviously the function is increasing and concave up because this is smiling in nature. So it has to be option A. This is decreasing, of course, and it is also concave up. So decreasing and concave up will be option C. Then over here, this is also the same thing, right? This is decreasing and it is frowning in nature. So concave down, decreasing and concave down, which looks like option D. And this is increasing, obviously, and it is concave down. So increasing and concave down because this is frowning in nature, which looks like option B. Okay, the table gives values for a continuous function. What is the AROC from 0 to 3? So what is the formula for AROC? That's y2 minus y1 over x2 minus x1, right? So we are going to say that it will be f of 3 minus f of 0 over 3 minus 0. What is f of 3? The functional value at 3 is 4. So 4 minus, what is f of 0? Functional value at 0 is negative 2 over 3. So this will be 6 over 3, which is just 2 over here, which is option C. Okay. Likewise over here, we need to find AROC between 3 and 9. So it will be h of 9 minus h of 3 over 9 minus 3. What is h of 9? From here, I can see that the h of 9 is negative 1. H of 3 is from here, it is 2 over 6. So negative 3 over 6, right? Negative 3 over 6 is just negative 1/2, which is option C. Okay, now we're talking about piecewise functions. So I think I'm gonna do just 56. I'm pretty sure you can handle 57. So again, we need to find what is the AROC between negative 2 and 4. The only thing that you need to take care about is so g4 minus g of negative 2 over 4 minus negative 2. Just make sure that at 4, which function is applicable, right? So at 4 is between 2 and 9. So obviously this function is applicable, and this is where you plug in 4. So if I plug in 4, 4 times 2 is 8, 8 plus 3 is 11. And then negative 2 is obviously in this interval. So if I plug in negative 2 over here, negative 2 square is 4, not negative 4, because it will be written as 1 minus negative 2 square, which is 1 minus 4, which is negative 3. So negative 3 over 6, so that's going to be 14 over 6, which is, I think we can reduce by 2, right? So 2 times 7 is 14, 2 times 3 is 6, so 7 over 3, which looks like option D. Okay, in question number 56, we are given that if the AROC is 2, then find the value of it. Almost similar concept, it's just that we need to find a different thing. So AROC will be given by k of 2 minus k of negative 4 over 2 minus negative 4, right? So this over here will be AROC is already given as 2, so I'm going to replace that by 2. What is k of 2? Clearly at 2 this function is applicable, so I'm going to replace this x by 2. So 4 times 2 is 8. So a minus 8, just be careful. What is k of negative 4? So we put negative 4 over here. Negative 4 times 2 is negative 8. Negative 8 plus 1 is negative 7 over uh, 2 minus minus 4, right? 2 minus minus 4. So this is going to look like 2 is equal to a minus 8 plus 7 over 6. If I cross multiply, then 6 times 2 is 12. 12 is equal to a minus 1. So adding 1 both the sides, 13 is equal to a, which means that a is 13. So it should be option C. That should be the correct choice. Okay, remember this guy? We need to figure out whether this is a linear model or a quadratic model, and along with the correct reason. So for this modeling, we first make sure that x is increasing by the same value. I'm not saying it should be 1, it should just be the same value. So if it happens, then you can just find the first difference, and then if first difference is same, it is linear. If not, then you can find the second difference. If that is same, then it is quadratic. Always remember that the difference is latter minus former. So it's 1 minus 3, right? 1 minus 3 is negative 2, 2 minus 1 is 1, 6 minus 2 is 4, 13 minus 6 is 7. Obviously, this is not same, so let's find the second difference. 1 minus 2 is 3, 4 minus 1 is 3, 7 minus 4 is 3. So yes, second difference is same, which means that it has to be a quadratic. Why? Because the rate of change is constant? No, obviously the rate of change is not constant, because had it was constant, it would have been linear. Uh, the next one is saying the rate of change is, sorry, the change in the average rate of change is constant. That's correct. The change of change is constant, right? Not the ROC. They are saying the change in the average rate of change is constant, which is absolutely correct. That is another fancy way of saying second difference. So it has to be option D. Okay, here they are saying that, I think that's the same question, right? Okay, let's do it then. What is the first difference over here? Obviously, x values are increasing by the same amount. 11 minus 1 is 10, 19 minus 11 is 8. This is, I believe, 6. This is, I believe, 4. So I think this is again going to be quadratic, because 8 minus 10 is negative 2. This is negative 2. This is negative 2. So isn't that again option D? Because quadratic, because the change in change is same. Okay, over here we need to figure out whether this function is decreasing or increasing, and then it's concave up or down from the table, but not the graph. So increasing, decreasing is pretty straightforward, because you just have to look at the y values. Obviously x is here increasing, and the y values are clearly decreasing, so it is decreasing. And for concavity, you need to find the ROC, and that's why our first difference, that's why I kept saying that it is latter minus former, because in those questions it won't matter, but here your answer will be exactly opposite if you will do former minus latter. So first difference is going to be 7 minus 14, which is negative 7. This is going to be negative 4. This is going to be negative 2, because 1 minus 3. And this is going to be negative 1. Obviously, these numbers are increasing, because in negative sense, if the magnitude decreases, then the number increases. We know that, it's in the number line thing. So since the ROC is increasing, and ROC increasing means it is the characteristic of concave up function, so it has to be option A. Likewise, over here we can see that the x values are increasing and y values are also increasing, so it is an increasing function, and ROC is going to be 3 minus 1, which is 2, 8 minus 3, which is 5, 18 minus 8, which is 10, and 50 minus 18, which is obviously what, 20, 30, 32, I think. So these values are clearly increasing, so it has to be a concave up function, because ROC is increasing in nature. Okay, that is the same thing, I'm pretty sure. Yeah, these two are similar questions, as same as the previous two, so I'm gonna skip. I'm pretty sure you guys can do it. Okay. Now this is important for your school, although AP is also like this, but in school this is pretty important. Which of the following could be an expression for gx? So we can see that it has two roots clearly. One is a negative root and one is a positive root. And unfortunately, that doesn't really rule out anything. But I know that for a positive root, this is a positive root, right? The multiplicity has to be odd, and for this one multiplicity has to be odd. So what is the difference? The difference is this one has a power of 1 and this one has a power of 3 or more, 3, 5, 7, 9, and so on. Why? Because whenever there is a tilt or it flattens out about the root, it means that the power is not 1. It has to be higher. So it has to be 3, 5, 7, 9, and so on. And if it just crosses without flattening out, then it is just 1 over, the power is just 1, right? So I know that for a negative root, the power has to be 1, and the power is 1 over here for the negative root. So I'm pretty sure it has to be either A or C. But then I have to make sure that for the positive root, I also have an odd power, not an even power. So it has to be an odd power, which is 3. So best choice is option C. I hope this makes sense. I can take a couple of more seconds to explain. From here, the roots are x equal to -3 with a multiplicity of 1 and x equal to 2 with a multiplicity of 3. So if it is a multiplicity, if it has a multiplicity of 1 at -3, it just passes through, which I can see is happening over here. And if it has a multiplicity of 3 at 2, it will flatten out a little bit, which is happening over here. Okay. Um, Here we are, okay, the x differs in the options, obviously with 0 and then power of 1 and then power of 2. So that's the first thing that I noticed. But clearly I can see that x cannot be an odd power because the curve bounces over here. And the curve bounces means that the multiplicity has to be even. So a is definitely gone, right? A is gone. Now, this looks like both are odd powers because it just passes through. The only difference I see in these is, obviously the positive roots seem to be a bigger number, right? I mean, just eyeballing the distance, and negative root seems to be a little closer to the origin. If I choose option B, it is going to give me the roots as -4 and 2. But I don't think so that works because -4 will be at further, farther than 2. So I don't think so. I'm going to go with this. -2 and 4. Yes, I think -2 and 4 is going to work. So it has to be either option C or option D because -2 and 4 are from both these. But then I look at the end behavior because here there is a negative sign on the outside. We can see that this function is going down, down. And if C is the answer, then I will see that the degree of this thing is 2 and 1 and 1, which is 4. So the degree is 4 over here. And the leading coefficient is negative because of this negative, which makes perfect sense because when leading coefficient is negative and the degree is odd, it actually goes down, down. Over here, it will go up, up in option D, which is not something that I want. So it has to be option C. Right. Over here, this is about solving polynomial inequality. So we need to solve for fx greater than gx. Fx is x squared minus 3x. This should be greater than gx, which is 3x minus 9. So this should be x squared minus, subtract 3x both the sides, so minus 6x, and add 9 both the sides, so plus 9 is greater than 0. And it feels like this is a perfect square, If you factorize this, this will be x minus 3, x minus 3 is greater than 0, which means that x minus 3 whole square is greater than 0. So everything is a solution except x equal to 3. Because if you make x as 3, this thing will become 0, which is not something that we need. But other than that, you put any x, this square will always make it positive. So that's just positive. So it has to be option B, everything excluding 3. All right, 95 to 98, these are similar types. So I'm going to try, I think 97, or maybe I can try 95 and 98 for you. I'm pretty sure you can handle the others. So we need to find the roots and their nature, like how many roots and what is the nature. So for roots, obviously I will equate x squared plus 4 and x squared minus 9 to 0, which means that x squared plus 4 has to be 0, which means that x squared should, and x squared minus 9 should be 0. Obviously from here you are going to get two imaginary roots, right? So two imaginary, two distinct, there you go. Two non-real roots. That's definitely something that I'm going to get. And apparently that's the only option, having two non-real. But anyway, we'll solve it completely. From here, x squared is equal to 9. So x is plus minus 3. So I'm getting two non-real and two distinct real as well. So it has to be option D. Over here, we again do the same thing. So obviously from here, I can see that x equal to 4 is one real root. But this doesn't look like I can factorize as easily. So I'm going to use a quadratic formula and see whether it gives me real roots or imaginary roots. So I'm going to say that x is equal to negative b plus minus the square root of b square minus 4ac over 2a, 2 times 1. So this will be negative 2 plus minus 4 minus 28 over 2. I don't think so. I need to proceed further because 4 minus 28 is a negative number and square root of a negative is imaginary. So it's going to give me two non-real zeros as well, along with one a real zero, which is x equal to 4. So it has to be option D. Okay guys, if you're finding these questions helpful, please like and subscribe, share the video. It will really help me. And if you need private tutoring, feel free to reach out. Right, now we are talking about end behavior of polynomials. So I don't think so. This is a biggie. I'm probably going to do that. 107 and 108 are pretty straightforward. I'm going to try 109 and 110 for you. In fact, 110 is also straightforward. So 109, I've seen students, what they do is to find the end behavior, they open up the entire, they FOIL it out. Not required, guys, not required, because you just take the leading term of the first one, you take the leading term of the second one, and just multiply those because the end behavior depends on the leading term overall. So this gives us negative 6 times x to the 5, and that can give us the end behavior, because if you put any x that is approaching to a positive number or positive infinity, this will give you a negative number, right? So when x is going to positive, the number is good, the expression is going to negative, so it has to be either this or this. And when x is going to negative, this negative raised to 5 is odd power is a negative number, and double negative will become positive. So when it's going to negative, it will become positive. So it has to be either B or D. So it has to be, I mean, why am I saying B? Because B and C are already ruled out. So it has to be only D, that matches with the expression over here. Again, I'm going to leave 110. This is pretty straightforward, just based on a couple of rules. Again, I have done a similar question earlier already, so I'm pretty sure you guys can handle this one. All right, let's talk about the end behavior of the rational function. So I'll give you the idea. Let's do question number 121. Again, it's all about the leading term. So you have to take the leading term of the top and the leading term at the bottom. And if you remember, we just compare the degrees, right? So here the degrees are same. So if the degrees are same, then the end behavior is same as the ratio of the leading coefficient, which is 2 at the top, minus 1 at the bottom. So negative 2. So negative 2 would mean that whether x approaches infinity or negative infinity, both are going to be 2. But over here, for example, the top has a higher degree. The degree of top is 5 and the degree of the bottom is 2. In such cases, the horizontal asymptote does not exist because end behavior is basically HA. But what is it? Whether that's infinity or minus infinity, that depends on how this, simplifies. So this, when simplified, it will become x cubed over negative 3. So if I put x as infinity in x cube over negative 3 or negative x cube over 3, obviously infinity cube is infinity, so that's a positive number, and there's a negative sitting outside, so it will be a negative number. So when x approaching infinity, it should approach negative infinity. So it has to be option A or D. And clearly when x goes to negative infinity in the same expression, this negative cube will be negative, double negative will become positive. So when x approaches negative infinity, it approaches positive. So this approaches negative infinity, and when x approaches negative infinity, this approaches positive infinity. So that has to be option D over here. Okay, I'm pretty sure you can handle 122. In 123, we need to solve this inequation. So pretty straightforward. It works exactly in a similar fashion as compared to polynomial. The only difference is you just have to take care of the points where that is equal to 0. Here we don't have to worry because it is greater than 0. But for example, you plot the roots first, which is negative 2 comes over here, because x plus 2 when equated to 0, it will give negative 2. When x plus 3 is equated to 0, it will give us 3. Then you put any number that you like, which is greater than 3, let's say 100. So if you put 100 over here, this will be positive. You put any number between negative 2 and 3, let's say 0. So 0 will make the top positive and the bottom negative. So negative. Any number that is less than negative 2, which is negative 100, so that will make this negative and this negative, and double negative is positive. And we are looking for where r is positive, so it will be negative infinity to negative 2, union 3 to infinity. But had the question was Rx greater than equal to 0. So don't fall into the trap of saying just blindly -2 included and 3 included. No. 3 will not be included because 3 is making denominator 0, right? So that's what I was talking about, that your answer will be only 2 included. 3 can still not be included. But at the moment, the answer is just option D. All right, guys, in these questions, we are talking about VAs and wholes and all those things. So they are saying that when f is sufficiently, the input values of x are sufficiently close to 2, which means that if x approaches 2, and you can clearly see that x minus 2 is a common factor at the top and bottom, right? So that's a whole. So when we want to find limit x approaching to 2 to this particular thing, we just cancel the common factor, right? Because we are just interested in the y value. So these are gone, and now we put 2 in instead of x. So it will become -2 times 2 plus 1, which is 3, 2 plus 10, which is 12. -2 times 3 is -6. -6 over 12 is -1/2. So it looks like it is option B. Here we are given that the graph of the rational function m as a whole at x equal to 1. So which of the following is the expression? Once again, if it has a whole at x equal to 1, then x minus 1 should be at the top and bottom both. So it cannot really be A, it cannot really be C. And the degree of the multiplicity of that factor at the top should be greater than or equal to the bottom. Here the bottom is more, so x equal to 1 will behave as a VA. But here the degree of the top is more, or the multiplicity of the top is more. It is 2 and this is 1. So x equal to 1 behaves as a whole over here. So it has to be option D. Okay, over here we are given that a function has a whole at x equal to -3, and then limit x approaching to -3 is 4. So which of the following could be the correct choice? Once again, if x equal to -3 is a whole, then x plus 3 should appear at the top and bottom both. This is x minus 3 at the top and bottom. I don't like that. X plus 3 appearing at the top and bottom. This is a potential candidate. There is no x plus 3 here, gone. And there is x plus 3 at the top and bottom, again, potential candidate. Now, all I have to do is find that where, when we plug in x's or limit x approaching to -3 will give me 4. Let's try B, or probably let's try D. So limit x approaching to -3 of x plus 3, x minus 5 over x plus 3, x plus 1. I think I'm going to cancel x plus 3. And if I put -3 instead of x, this will be -8 and this will be -2, which is 4, which is exactly what I need. So it has to be option D. Right, over here we have a rational function having a 0 of x equal to -1 and a whole at x equal to 2. So which of the following could be R? So I know that x plus 1 exclusively, x plus 1 should be at the, x plus 1 should exclusively at the top, not at the bottom, because it is a 0. And likewise, x minus 2 should be, somewhere at the top, somewhere at the bottom. Okay, so it looks like I need to factorize these things and figure that out. If I factorize A, it will be x plus 2, x minus 1. I don't think so. I'm even going to factorize denominator because I don't see any x plus 1 at the top. That's what I want. So that is gone. Over here, I will have x minus 2, x plus 1. So yeah, now we are talking. X plus 1 is at the top. That's what I want. And x minus 2 is at the top as well. That's exactly what I want. But the bottom matters. Bottom will be x plus 3, x minus 2. I think we have a winner because x plus 2 is x minus 2 is at the top, x minus 2 is at the bottom, so that creates a whole. And x plus 1 is at the top, which will create a 0 at x equal to -1. There's no need to check the other options. It's just option B. Over here we have a 0 at x equal to -4, which means that x plus 4 should exclusively be at the top. Just by looking at x plus 4, this is ruled out and this is ruled out. Oh, interesting. We are just left with option A and D because x plus 4 is here and here. and then we have a VA at x equal to 3. So x minus 3 should be at the bottom, and I really don't see x minus 3 at the bottom over here. So that's gone. It has to be option D, because x minus 3, although is at the top and bottom both, but here the degree or the multiplicity of this factor, or the degree of the factor at the bottom is more than the top. And when that happens, it has to be a VA, not a whole. So it has to be option D. That should be our answer. All right, the next one, we have a 0 at x equal to 5, and I'm pretty sure you guys can handle this, so I'm gonna skip this. Right, now we're talking about binomial theorem, Pascal's triangle, guys. I hope you remember. So using that, we need to figure out what is x minus 4y to the 5. So I'm going to quickly make a Pascal's triangle here. It starts from 1, then it's 1, 1, then it's 1, 2, 1, then it's 3 and 3 and 1, 1, then it's 4, 6, 4, and then 1, 1, then it's 5, 10, 10, 5, and then 1, 1. So this is, remember, it starts from 0. So this is 0, 1, 2, 3, 4, 5, and that's what we want. Now the structure looks like you start from this x and the highest power, so x to the 5, and then you keep decreasing the power. So x to the 5, x to the 4, x to the 3, x to the 2, x, and then just 1. Then you start with the other guy, 4y, and then do the same thing, but in the opposite direction. So you start from here, which is 4y to the 5, then 4y to the 4, then 4y cube, then 4y square, and then 4y, and then 1. And now you just attach the Pascal's coefficient. So that starts from 1, and this is 5, and this is 10, and this is another 10, and this is 5, and this is 1. And then if the sign between those two people are negative, then you toggle the sign. You start with plus, then put minus, then put plus, then minus, and then plus, then minus. So that should be our answer, which looks like this one, right? Why not D? Because what is the difference between, oh yeah, not D, because D is all negative, right? That won't work. So it has to be C, because that has to toggle the signs, which is exactly what we want. So it has to be option C. Okay. The binomial theorem can be used to expand what is the coefficient of x squared? So isn't that the same thing over here, because we need to again expand this up, which is 4, by the way. I'm not really going to make the Pascals again. 4 is right here, and I'm going to start with x to the 4. So x to the 4, x cube, x square, x and 1 not required, although. And then I'm going to start with 7. So 7 to the 4, 7 cube, and then 7 square. I don't care about the others. And then in between there is a negative. So I'm going to, sorry, first I need to put the Pascal, guys. So it's 1 here, 4 here, 6 here, and then again I do not care, because I'm just focusing on x square, and then plus, minus, plus, minus, plus. So this is my answer, which looks like 6 times 7 square. Negative 7 square and 7 square is basically the same thing. So 6 times 7 square is just option B over here. That should be our answer. Okay. Here we need to find which of the following statements is correct. Then they are talking about HA. Okay, this is a pretty interesting question, because the top is actually going to simplify, or let me put it in another way. We need to simplify the top before answering this. So x minus 2 whole cube is going to be x cube minus 3x square 2 plus 3x2 square minus 2 cube. If you're wondering what on God's green earth I just did, I used a minus b whole cube identity, which is a cube minus 3a square b plus 3ab square minus b cube. So if we do this, and if we plug that in here and then subtract x cube, remember I have a minus x cube as well. So don't you think that these two guys are gone? And I will be left with negative 6x square, because 3 times 2 is 6, then plus 4 times 3 is 12, 12x minus 8, and divided by 3x square minus 2x plus 7. And now I think you very well know what the HA is because the degree of the top and bottom is same. So the answer will be the ratio of the leading coefficient, which is just -6/3, which is -2. We do have an option of y equal to -2, so it has to be option C. That's what I'm going to mark. I'm pretty sure you guys can similarly handle this one. The only difference is here you have to open this up using a Pascal's triangle, and then the x to the 5 will be gone, and likewise you can just proceed. If you have any questions, just post it down in the comment section. I would be happy to help. Okay, now we're talking about transformations. This is important. Transformations along with the domain and range. Okay, range is given. We need to find what is the range of G. So I've been telling this to you various times, and I have some 1.12 ABCD worksheets as well in my playlist. Feel free to check those out. That the range only depends on vertical transformations. So there are two vertical transformations that I see. One is this -2 and one is +8. So it looks like the first thing that they did was to vertically dilate by a factor of 2. So I'm going to multiply this -6 and 4. So it will become -12 y, and then this will become 8, right? If you're wondering why have I not multiplied y with 2, because I'm looking for the new y, right? It doesn't really matter what this changes to. I'm just interested in the numbers. Then they multiplied a negative sign outside, so this became 12 greater than equal to y greater than equal to -8. I hope you understand that the signs will be flipped when I multiply by a negative. And then we add 8 all the three sides, so 12 plus 8 will become 20. This will become -8 plus 8 is 0. So the new range is 0 to 20, which clearly looks like option C. That should be our answer. Okay, in the next one, they are saying that if this is a point on the graph, then what will be the point on the transform function? Pretty straightforward. There is no change in the x value because there is no horizontal transformation anywhere. So horizontal or x point will still be -4. But the y point looks like to be multiplied by 3 first because by a vertical dilation. So 5 times 3 is 15. And then you add 2. So 15 plus 2 is obviously option B. That should be the answer. I'm pretty sure you guys can handle 163. I'm going to try probably 164 for you and 165 as well. So over here, they are saying that domain is given, G is given, and a point is given. So again, the same story, which of the following is the point on this curve? Yes, there is a horizontal transformation. As you can see that this guy is moved 3 units to the, not right, it is left, it's counterintuitive. So when 5 goes 3 units to the left, 5 minus 3 is 2. So x value should be 2. So it has to be either A or B. And then y value looks like multiplied by 2 first, which becomes 8. Then reflection, so it becomes -8. Then add 1, so it becomes -7, which looks like option A to me. So yeah, that should be option A. The next one is we have a VA at x equal to 3 and HA at y equal to -2. If fx has been transformed to this guy, then what are the new HAs and VAs? We need to figure that out. So again, the same thing, x equal to something, x is changed by horizontal transformations, and it looks like this function is moved 7 units to the right. So when 3 is moved 7 units to the right, 3 plus 7 will be 10. So do I see x equal to 10 somewhere? I don't think so. So it is not C or D. And when y equal to -2, there are two transformations. First it is multiplied by 4, which is 4 times -2, which is -8, and then added by 1, so it will become -7. So y equal to -7, yes, we have a winner. We do have that in option B, so that's the correct choice. All right, guys, moving on to graphing transformations. Over here, we are given a function and we need to figure out what is the graph of 2 times kx plus 1. Remember, there is no change in the x value because there is no horizontal transformation anywhere. So graph should still be between -3 and 2. So that automatically rules out option B because it starts from -2 and ends at 4, and also rules out option C because it starts from -4 and goes to 2, which is not allowed. It should be between -3 and 3. Now take any point and figure that out. Let's say this point is -3, -2, and the y value is first multiplied by 2, so it becomes -3 comma -4, and then added by 1, so -3 comma -3. So -3 looks like to be an option A. Option D has -3 -2, so that won't work. So I think I'm going to go with option A. Right. Now this function over here, the graph of which of the following functions is the image of the graph K after a horizontal translation of the graph K of 4 units? Isn't that pretty straightforward? That's it. They're using some fancy words because all they are saying is if I want to move K 4 units to the right, then how will the graph look like? Obviously, you will just replace this x by x minus 4. So it looks like it is option B because x has been replaced by x minus 4. Honestly, I don't even need to read the reason because that's the only option having x minus 4, right? 178, if it has been dilated horizontally by a factor of 3, remember, horizontal dilation is counterintuitive. So if it is dilated by a factor of 3, x should be multiplied by 1 over 3. And remember, only x should be multiplied by 1 over 3, not this -4. So I'm looking for an option where this x is multiplied by 1 over 3, not this, not this, not this. It has to be option C because x is multiplied by 1 over 3. So it becomes x over 3 over here. They're saying the table shows da-da-da, which are the following best models, da-da-da. Isn't that the same thing? Honestly, we just find the first and second difference. X values are increasing by the same, amount. I'm pretty sure you guys can handle it. You know what? I'm just going to skip that. I'm pretty sure you can do it. And then we have this last question, funky question. Some algebra 2 students, algebra, this question is often in algebra 2 as well. So, but anyway, let's tackle this. So there is a square sheet and some square bases of x by x are taken out from the corner and then it is converted into an open box by folding it. So which of the following is the domain? Okay, first off, we want to write what is the volume of this. So remember that if you take out x from here and x from here, this guy is 24 minus 2x. Likewise, this is also 24 minus 2x. And when you fold this, if you're able to imagine, this x is going to rise up and become the height of that box, right? So the box is pretty much going to look like this. I'm saying that this guy will now be x, while this is 24 minus 2x, and this is also 24 minus 2x. So the volume is obviously length multiplied by width multiplied by height. They're asking what is the domain. So obviously it makes sense that how can this side and this side and this side, essentially these two are same, go negative? It cannot, right? So x should be greater than equal to 0 or ideally greater than 0. But yeah, if you don't take out any x, then there's no box. But yeah, there is no greater than 0 option. So it has to be greater than equal to 0. And then 24 minus 2x should also be greater than equal to 0 because you cannot take out any x that will not even leave any side of the sheet, right? I hope you understand what I mean. So from here, I'm just going to say that I'm going to multiply negative sign both the sides. So 2x minus 24 should be less than equal to 0. 2x should be less than equal to 24. So x should be less than equal to 12. So it looks like option C matches with x is greater than equal to 0 and x is less than equal to 12. So we're given that the values of the terms of the geometric sequence are graphed over here, in which of the following expressions gives the nth term of the geometric sequence. So we know that geometric sequence Gn is given by G1 times R to the n minus 1, either this, or Gn is also given by G0 R to the n. But I think I'm not sure if this will make sense because we are not given G0 anywhere. So let's go with this one, the above one. G1 is basically the value at 1, which is just 4. So I'm just going to replace G1 by 4. and r is the common ratio, which is the latter term, which is -2, over the former term, which is 4. So that's -1/2. So r is -1/2. So the value of gn comes out as g14 and r, which is -1/2 to the n minus 1, which looks like option B to me. So I think that should be our answer, if it makes sense. Okay. Right, in this question, we again need to find the equation of the geometric progression. I think it feels like these two will make sense because these two are giving me a hint that we are starting from g0. So let's write the general term gn is equal to g0 times r to the n. G0 is 10 and r we need to find out. So just be careful here that when we find the radius, the ratio, this is for the second term and this is for the 0th term, right? So you cannot really just take the ratio of these two and get the common common ratio. You have to be a little careful here. So we know that G0 is given by 10, G2 is given by 5. So if I write the equation G2 is equal to if I write the general equation Gn is equal to G0 times r to the n, and I replace n with 2. So G2 is G0 r square, G2 is 5, G0 is 10, and r square is just r square. So I got 5 over 10 is equal to r square, which means that r square is 1 over 2, which means that the value of r is 1 over 2 to the 1 over 2. Right, and this r I'm going to sub in over here. So this is going to look like 10 times 1 over 2 to the 1 over 2 to the n, and this will look like 10 times 1 over 2 to the n over 2. So that is the value of gn, which is option C, I think. Yeah, option C makes sense. Okay, all right. A large theater has rows arranged in a way that the number of seats in each consecutive row forms an arithmetic. If the fourth row contains, okay, so I'm given A4 as 30, and the eighth row contains, so I'm given A8 as 54, then which of the following are the number of seats in the 10th row? First, we need to figure out what is the common difference. So the common difference is obviously we can treat these 2 points as the points lying on a straight line. I hope you know this shortcut. If any 2 points are, any 2 terms are given, then consider these as points as if they are lying on a straight line, and just find the slope, which will be your common difference. So it is 54 minus 30 over 8 minus 4. So that's, I think, 24, right? Over 4, which is just 6. Now I need to figure out what is A10. So I know that AN is equal to A K plus n minus k times t. That's a general formula for arithmetic. So in our case, I need to find A10. So n is 10. And we can take the reference as probably either A4 or A8, whichever you like. I will take A4. So A4, k is 4, 10 minus 4, and common difference is 6. So A10 will be equal to A4. A4 is 30 plus 6 times 6 is 36. So that's going to be 66 over here. That's going to be A10. And yeah, we have that in the option. So it should be B. Okay. Let an represents an arithmetic sequence where this happens and find the value of A12. Isn't that literally the same type of question? So I'm going to find the common difference over here, which is 10 minus 22 over 6 minus 3, which is negative 12 over 3, which is negative 4. And A12 in that case is going to be, I'm just using the general term, AN is equal to AK plus N minus K times T. A12 will be equal to A3 plus 12 minus 3 times common difference is minus 4. So A12 will be equal to A3, which is 22, plus 12 minus 3 is 9, 9 times 4 is 36, so minus 36, and 22 minus 36 is negative 14. So yes, fortunately that is in the option, so the answer is option B. Okay. The next one is the table gives values of the sequence Sn and uh, which of the following statements about Sn is true? Is that arithmetic or is that geometric? That's the first question. Well, clearly we can see that if we take the difference, for example, 6 minus 12, negative 6, 0 minus 6, negative 6, negative 6 minus 0, negative 6, negative 12 minus 6, negative 6. So for sure, it is not geometric, it is arithmetic because the difference is same. And yeah, it's it because successive terms have a constant difference, and that's what we want. Proportional change is the property of geometric, so that's not what we want. Okay. The table gives the value of the sequence, which are the following statements about Sn is true. Again, I think the same scenario, but this time, yeah, I mean, I forgot to tell you that just make sure the n values are increasing by the same gap, right? In this case, yes, it is. And in the next question also, it is. I'm not saying that the gap should be 1. I mean, the gap can be 2 as well. It can be like 2, 4, 6, 8, 10. I won't really mind. The gap should just be same. So here you can see that if we take the ratio 2 over 1 to 4 over 2 to 8 over 4 to 16 over 8 to, so the common ratio is 2, which means that it is a geometric sequence because of the constant proportional thing. So 8 is D. That makes sense. Okay. Now we are given an exponential function, and they are asking us that what is the end behavior. So guys, I hope you know the parent functions, that if we have a times b to the x, and if a is positive and b is between 0 and 1, which is happening in this case, the curve is an exponential decay. So it looks like this. So clearly, if we see this, if x is approaching to positive infinity, this thing is going to 0. So x is going to infinity, this is going to 0. Honestly, this is the only option that has this. But yeah, if x is going to negative infinity, it should go to infinity, which is also matching. So it should be option D. That should be our uh, answer. Okay. What if I have a times b to the x where a is greater than 0 but b is greater than 1? This time it will be an exponential growth. So it will look like this. So it will become 0 if x is approaching to negative infinity. As you can clearly see that it is approaching, flattening out about the x-axis. So when x is approaching negative infinity, it should be 0, which is in these two options. And when x is approaching to positive infinity, it will just go to positive infinity. That is the other option, which is over here. So option C is the best choice. The function h is given by this, and which are the following decides. Don't be confused just because this is less than 1. It doesn't matter. All we care about is this should be positive, and if this is greater than 1, then literally it follows the same thing as the question number 14. So I think they have not even changed the options. It should be C as well over here, just as the above one, right? A times b to the x. And yeah, over here, just be a little careful because although it is a times b to the x, which would have been like this, but this negative sign flips it about the x-axis. So the actual graph will be like this because it has been flipped. So when x is approaching to negative infinity, it is going to 0. Yes, that is still happening over here. But when x is going to infinity, y is going to minus infinity, which is going to be this one. So it has to be option A. That's the answer. Okay. Here we are given a table and we need to figure out that what are the properties of A and B. So honestly, just first off, see that whether that's an exponential increase or growth or decay. Obviously, that's a growth. The numbers are increasing. So growth means A is positive. It is already given that A and B are positive. So it means that A is obviously positive and B has to be greater than 1 if it wants to be an exponential growth, which matches with option D over here, right? 22. The exponential function, again, I think the same scenario, but this time, if you notice, actually nothing. Uh, Still, it is increasing in nature, right? So I don't think so anything has changed here. It is still increasing, it is still a growth, and A is anyway positive. So yeah, I will again go with option D. A is positive and B is greater than 1. Yeah, this one definitely you can see that the y values are decreasing with time. So it is a decay, and if it is a decay and a is already positive, this means that b should be between 0 and 1. So a is positive and b is between 0 and 1 and decay. So it has to be option A. That makes sense. Right, I hope these questions are making sense to you guys. If you're liking this video so far, please like and subscribe. Please share it with your friends as well, so that it can help them and it will help me as well. Okay, which of the following statements true about this function? Now they are talking about increasing, decreasing, and concave up, concave down. All right, so this is an exponential decay. I think we both agree with that. We just saw the form earlier. Exponential decay function looks like this, which means that obviously it is a decreasing function. And it is also smiling in nature. So it's decreasing and concave up. So I'm going to say, yeah, this option makes sense, decreasing and concave up. So it should be C. Likewise, over here, this is an exponential growth because A is positive and B is greater than 1. Exponential growth function looks like this over here. It's increasing and concave up, of course, because it's increasing clearly and it is, smiling in nature. So it should be concave up. Okay. So the following statements is true about the exponential function. This once again we are talking about a similar situation. This is again an exponential increase, guys. 3 times 5 to the x, so it will look like this. So I think this is also increasing and concave up. Nothing has really changed. Okay, 27, it is negative this time. So it would have been an exponentially increasing function, but because of this negative, it is now reflected about the x-axis. So it is a decreasing function, of course, and it is also concave down because it is frowning in nature. So decreasing and concave down is option D. And finally, this function would have been an exponential decay because this b is less than 1. But since there is a negative sign outside, so it has been reflected about the x-axis, which means that it is obviously increasing in nature. You can see it is increasing and frowning as well. So concave down. So increasing and frowning, or increasing and concave down, is an option B. So that should be our answer. All right. They're saying that this function is a quadratic or exponential. Obviously, that's an exponential, so A and B are definitely not possible. And why is it exponential? Because the values are proportional over equal length, or average rate of change can be given by a linear function. No. Average rate of change can be given by a linear function is the property of quadratic, not exponent. So D is way wrong. It has to be option C, where the ratios are same. And yes, that is indeed the property of the exponential function, right? Okay. Question number 36. So these guys are pretty important in AP. For some reason, they like these type of questions. So we need to rewrite the same question in another way. Okay. So if we keep the 36 as 36, can I write 4 as 2 square? And 2 square to the x is just 2 to the 2x, right? So it has to be option D. 36 is D. The function j is given by this, which of the following is equivalent form. So this will look like 3 times 4 to the x plus 2 is 4 to the x times 4 square. 3 times 4 to the x times 4 square is 16, and 16 times 3 is 48. So 48 times 4 to the x, which is definitely option B. All right. In the xy plane over here, okay, this is about transformation. So they are saying that if this guy undergoes a vertical dilation of the exponential function k, uh, okay, so they are saying that this function undergoes a vertical dilation and becomes this. So what is its equivalent form of h that expresses h as a horizontal translation of k? Okay, I hope you understand the question. They are saying this is a parent and this has been vertically dilated, as you can see, by a factor of 9 and it becomes this. So can I write h but not as a vertical dilation but as a horizontal translation of k? Yes, indeed, because 9 times 3 to the x can be written as 3 square times 3 to the x, which is 3 to the 2 plus x. And obviously this is going left by 2. Well, they just need the form, by the way, which is just option B. But yeah, we can also say that it is going left by 2, and that's how you will get this option. Think this is again something that we need to manipulate, because this has undergone a horizontal dilation of 3 to the x, and that is equivalent to this. So 3 to the root 3 is just 3 to the 1 over 2 to the x, and 3 to the 1 over 2x is just 3 to the x over 2, which looks like option A. Okay. Over here, the increasing function c gives the number of cars that are stuck in traffic due to the lane closures. They are saying that if the model can be constructed to represent this data, then which of the following best applies to this situation? Okay, the way I see it, this is exponential. Obviously, because we are talking about 2.5, but yeah, of course, look at the common ratio, it's same. Right, every number is multiplied by 3 to get the next number, so it is a common ratio. And you can see the x values are also increasing by the same gap, right? So if it is 3, then I'm looking for an exponential function having a b value of 3, which is only happening in option D. So that should be our answer. Likewise, they are saying over here that the number of cars are increasing by 15% each hour, and at t equal to 0 there are 54 cars on the highway. So the initial value is 54, and that's why you can see that every option has a 54 over here. And every hour it increases by 15%. So it is something like 50 times 1.15 to the t, or to the h, because h are the number of hours. But they are saying that if I now represent time in minutes, then what will be the equivalent? Okay, this is a very popular question where they give a unit and then ask you to convert it into a different unit. So if this is in hours, then if you want to convert this into minutes, then you might think that 1 hour is 60 minutes, so just replace by 60t. Actually, it's counterintuitive. 1 hour is 60 minutes, so it will be replaced by t over 60, right? That's how it works. So it has to be option C and not option D. No, the option D is wrong. It should be option C. Think about it like this. If you replace t by 60 minutes, which is basically 1 hour, 60 over 60 will become 1. And if you replace h by 1 hour, it will also become 1. And these two will be equal. And that's what I want. I want both of them to represent the same situation. So it should be t over 60. All right, guys. Function model validation, competing function model validation. All right, guys. This is, I think, about residuals. And if you remember, we talked about this earlier, that if the residuals are showing a pattern, then the model is not appropriate. Definitely there is a pattern over here. So it is not appropriate. Why? Because there is a pattern. So this has to be option D over here. So that the regression model, whichever we have used, if we are plotting the residuals, it is showing a pattern, so it is not appropriate. Okay. Over here as well, you can see that if this is the regression model over on the left, and this is the residual plot over on the right, which is obviously showing a pattern, So will we say that the model is appropriate? Obviously, model is not appropriate. It is not appropriate. And is this exponential or quadratic? Obviously, that's an exponential regression. So it has to be option D, that it is used in, it is an exponential regression, but the model is definitely not appropriate. So that's how we answer it. Okay. Composition of functions. Okay, this is important, guys. So let's talk about the first question. So we are given that a table is given showing some values of f and g at some values of x, and we need to find that if h is this, then what is h of 9? So h of 9 is given by g of f of 9. F of 9 is, I think, over here, which is just 5. And g of 5 is, I think, over here, which is 4. So the answer is 4, and yes, that is in the options. Here we need to find k of 3. So k of 3 is given by f of g of 3. What is g of 3, guys? At x equal to 3, g is 5. So it's 5. And what is f of 5, guys? At x equal to 5, f is 8. So the answer is 8 over here, which is option C. Okay. Let h be defined. This is again the same scenario. We are just given two different graphs here. So h of 8 is going to be g of f of 8. And what is f of 8? If I read this, this is 8 and the y value is 1. So this is going to be g of 1. And what is g of 1, guys? At x equal to 1, it is minus 2. So this has to be negative 2, which is option A. That's how it works. Okay, over here we need to figure out k of 9. So k of 9 will be f of g of 9. What is g of 9, guys? G of 9 is over here, which is just 3. G of 9 is 3. And what is f of 3? F of 3 is going to be over here. At x equal to 3, f is minus 2. So this is minus 2 over here. So our answer should be option B. Okay. Okay, this is pretty interesting now. We are talking about inverse functions. The graph of the piecewise function f is given. So we need to, and there is a function g which is the inverse of f. So what is the domain of g? Remember that for f inverse, or for f and f inverse, the domain and range swaps. In other words, the domain of f is the range of f inverse, and the range of f inverse is the domain of f. So if they're asking me the domain of f inverse, because g is f inverse, I'm basically looking for the range of f. And the range of f is negative 2 to 3. So negative 2 to 3 is the range, which has to be option C. That should be the answer. Okay. The function k is the inverse of h. What is the minimum value of k? Obviously, if you're looking for the minimum value of k, you're looking for the minimum y value of k. So minimum y value of k, or minimum y value of h inverse, is basically the minimum x value of h, because they are inverse of each other. So what is the minimum x value of h? Negative 3, clearly. So our answer is negative 3. I hope you are able to understand the logic. It's just about reversal, swapping the domain and range, and that's the only trick over here. Okay. The table gives the increasing function. What is the value of f inverse 4? So f inverse 4 means the corresponding x value of the function fx when its y value is 4. So when is the y value 4? It is at 6. So the answer is 6, which is option D. Okay. Over here, we are given the table that gives an invertible function. So what is the value of f inverse g4? G4 is pretty straightforward. This is 4. This is g. So that's 7. So what is f inverse of 7? F inverse of 7 is the x value when f is 7. So f is 7 right here. Its x value is 2. There you go. Answer is A. Okay, f g inverse of f of 2. What is f of 2? F of x equal to 2, f of 2 is just 7. So g inverse of 7. G inverse of 7 means the x value when g is 7. G is 7 right here, so its x value is 4. So there you go, 4. What is f inverse g inverse 7? Let's be a little careful here. G inverse f inverse 7 means the value of x when y when f is 7. So f is 7 here, x value is 2. So I'm looking for g inverse 2. G inverse 2 means the x value when g is 2. So g is 2 here, x is 7. So our answer is 7, which is option D. I hope you understand this, guys. Feel free to pause and absorb this, or watch it again, but I'm pretty sure you will get it. It's just about f and f inverse and reading backwards. And the last one, f inverse, f of g inverse 2. G inverse 2 is the x value when g is 2. G is 2 right here, so its x value is 7. So what is f of 7? Pretty straightforward. At x equal to 7, f is 5. So the answer is 5 over here. Okay. The function h is increasing and the graph of h is concave up. Let k be the inverse. Then which of the following statements about k is true? Remember that inverse, a function and its inverse are always mirror image about the line y equal to x, right? So assume a hypothetical function h which is increasing and concave up, probably something like this. If I take the reflection of this about y equal to x, it will look like this, which means it is still increasing, but now frowning, which means concave down. So it has to be option B. That's the correct choice. It was a good conceptual question, I would say. All right, guys, moving to logs. The function is given by log of x with base 8. What is f of 2? This is all no cal, guys. So f of 2 is equal to log of 2 with base 8, which can be written as log of 2 over log of 8, change of base property, which can be written as log of 2 over 8 can be written as log of 2 cube. So this can be written as log of 2 over 3 log 2. Log 2 gone, and we are just left with 1 over 3. 1 over 3 is option C. That should be our final answer. Okay, you have to find g of 1 over 9. Likewise, we are going to solve this one. Well, I'm running a little out of space, sorry. But yeah, I think I'm gonna do that over here. So that's gonna look like log with base 3, 9 to the minus 1. This can be written as minus log 9 with base 3, because log has a property that minus is thrown outside. 9 can be written as 3 square, and 2 can be dropped outside. So the answer is negative 2. Why? Because log 3 with base 3 is 1. So the answer is option A. Okay, h is given by this if the input value in the domain of h yields an output value of 1 over 2. In other words, they want to know at what x is y 1 over 2. So I will solve it like this. Log of x with base 4 is 1 over 2, which means that the value of x is 4 to the 1 over 2, right? I hope you know what I did over here. Whenever you want to get rid of the log, keep the x as it is, throw the base over on the other side, and whatever is on the other side, raise it to the power. So this is going to look like 4 raised to 1 over 2, or root 4, and root 4 is just 2, which is option D. Okay. We are given that P is this, R is this. For what values will P and R intersect? So they will intersect whenever they are equal, of course. So we have to set log of x with base 10 equal to 1, which means that again, the same anti-log thing. X is equal to 10 to the 1, which means that x is just 10. So it has to be option D. Okay. Question number 81 and 82. So the function g is given by this, which of the following statements about the inverse of g is true? Okay, inverse, how do we find inverse, guys? We replace y with x with y, and then isolate y. So let's replace y with x with y, and isolate y. So this, if we flip the omelet, this is going to look like log of y with base 4 is x. So y is equal to 4 to the x. That's going to be the inverse. They're also asking what is the domain of the inverse function. So obviously domain of inverse function is basically the range of the original function, and range of the original function is all real values, because the log function with a base of 4, whenever the base is greater than 1, looks like this. So the range is all real values. So the domain is also all real values, which has to be option C. Okay. The points are on the graph of the exponential function. Which of the following statements about k equal to log of x with base b is true? I hope you understand without even solving that b to the x and log of x to the base b, they are inverse of each other, right? And if these points are on this function, then this would mean that the x and y, if we swap, they would be on this function. I know there are no options. I unintentionally clipped it out, but the options were that which points are on the k function. So the answer will be 1 over 8 comma negative 3 and 16 comma 4. These points are on the k function because they are inverse, so x and y will just swap. The table shows the values for the function k at the selected values. Then which of the following, here's the table, guys, by the way. So k is modeled by exponential or log. Okay, so since the x values are increasing by the same gap and the y values are, if you notice, are increasing proportionally by a factor of 3. If I keep multiplying 3, I'll keep getting the next number. So obviously this is exponential because the input values changes proportionally. No, output values changes proportionally as input values increases by equal interval. So that's definitely correct. It has to be option B. That should be our answer. Okay. Which of the following statements about f is true? So for that, we need to know the graphs. This graph will be like the parent with a base greater than 1, since the base is 10. So it looks like this. So clearly this is increasing, and also clearly this is frowning. So increasing and concave down, B. This one, of course, look like just the blue one, but this negative one flips it about the x-axis because that's a reflection. So that's just going to look like this one, which is decreasing, of course, going down, and smiling. So decreasing and smiling will make it decreasing and concave up, which is C. Okay, let g be a logarithmic function. So which of the following statements about the h is true? I honestly don't really care about the vertical translations like 3 because it's not really going to make any difference in the attribute of it, like increasing or concavity. Don't you think, guys, this portion and this portion will obviously look similar because that's the same thing. The base is still greater than 1. So it is just going to match the green one, which is again decreasing and concave up. So it has to be option C. This question is about the end behavior, which also depends on, of course, the graph. So log with base 10 obviously looks like this. So if x is approaching infinity, the y value also approaches infinity, which has to be option B. And if x is approaching 0 plus, it has to approach negative infinity. So that's why option D is incorrect, right? It's just important to understand both side behavior. Okay, simplification of logs. So this is mostly about the properties of logs, guys. I hope you have memorized those. If you haven't, it would be a good idea to revise those. For example, over here, I'm going to use the property of log of a over b, which is log a as in numerator minus log b as in denominator. Okay. Log of a times b can be written as log a plus log b. And this can be written as log with base to z. Make sure to put a parentheses because later on this negative sign will be distributed. And this 3 is going to jump outside as per the properties of log. So this is going to be 3. So this will look like log of 5 with base 2. Likewise, this 2 is going to jump out. So 2 log of y with base 2 minus 3 log z with base 2. So this is going to be option B. That should be our final answer. Sorry, not B, right? 3 log 2 with, sorry, not B, C. My bad. Yeah, C is correct. Okay. Likewise over here, even if it is ln or natural log, it's not really going to change anything. So that will be ln of 2e to the 4 minus ln x cubed. This is going to be ln 2 plus ln e to the 4 minus ln x cubed. Ln 2 is just ln 2. 4 is going to drop outside. So 4 ln e and ln e is 1. So it is just 4 and then minus 3 ln x. So 4, which is in option A and B, ln 2 and minus 3 ln x. Looks like option A, right? It matches with option A. So the following is equivalent to this one. So this is about condensing the logs. So 2 log x can be written as log x square. 3 log y can be written as log y cube, which is going to be log of x square over y cube, which has to be option C. Okay, so the following expressions is equivalent to this. So once again, this is change of base properties, change of base property of log, guys. So log of a with base b can be written as log of a over log of b. This is just a property, guys. I don't know what to explain here. It's just a property. That's how it works. Likewise over here, log of 9 with base 4 can be written as log of 9 over log of 4. Obviously, you don't see that option anywhere because this base can literally be anything. In our case, if you look at option D, the base is E. Although no one writes like this, of course. Log with base E is written as ln. So it will be ln 9 over ln 4, which has to be option D. That should be the answer. Okay. If fx is ln x, then what is this? So yes, definitely we can do this operation. So that's just going to be 2 times ln w, because f of w is just ln w, minus f of z is just ln z, which is going to be equal to ln w square minus ln z. And ln a minus ln b is ln a over b. That's the formula to condense the log. So it has to be option B. Okay. We are talking about question 106. Here function is given over here and gx is 1. So what is the x coordinate of the point of intersection of f and g? So it's as simple as solving for f and g both. So I'm just going to equate both of them, which means that log with base 10x plus 3 minus log with base 10x should be equal to 1, right? That's how you find the point of intersection. Log a minus log b is log a over b, which is equal to 1, which means that x plus 3 over x is equal to 10 to the 1, which is 10, which means that x plus 3 is equal to 10x, which means that 3 is equal to 9x, which means that 9x is equal to 3, which means that x is 3 over 9 or 1 over 3, which has to be option B. Once again, the same thing over here, that we need to find where will these intersect. So we can just do that. Natural log of 2x plus 1 is equal to 2 times ln 3. Which means that natural log of 2x plus 1 is equal to ln of 3 square because this 2 will jump on the power and 3 square is 9. And if ln of something is equal to ln of another thing, so 2x plus 1 is 9, which means that 2x is 8, which means that x is 4, which has to be option D. Honestly, guys, these two questions are again almost similar, right? Almost similar. So I'm pretty sure you guys can handle this. Just be careful that there is an option of there is no value of x, because whatever solution you get, make sure to check that whether it is not an extraneous root. So these logs should not really go negative or something inside, guys. Otherwise, there is no such value of x, right? Just be careful with that. Okay, I'm going to solve 1, 1, 1 for you. So that's going to look like ln a plus ln b is ln of a times b. So it will be 2x plus 3 and x minus 1 is equal to ln of x squared plus 6x minus 9, which means that ln of 2x squared plus x minus 3 is equal to ln of x squared plus 6x minus 9. If ln of something is equal to ln of another thing, it means that those two guys are equal to each other. This would mean that I will say 2x squared plus x minus 3 will be equal to x squared plus 6x minus 9. You can disregard these options, guys. These are for a different question. For this one, there are no options, but we are just going to write our answer as a free response. So this is going to be bring everything on one side, so it'll become x squared minus 5x plus 6 is equal to 0, which is just x minus 2, x minus 3 is 0, which means that x is 2 and x is 3. But don't blindly accept these answers. Just make sure that these are not extraneous. So if I put 2 here, yes, that's positive, it will work. 2 here, yes, that's okay. 2 here, yes, that's positive. So all good. If I put 3 here, yes, all good. 3 here, 3 minus 1, positive. 2, all good. 3 here, yes, positive. So yes, 2 and 3 are both acceptable. So this is my final answer. Okay. The same situation now, but with exponential. So with exponential, when are they intersecting each other? So I'm going to do 119 for you to start with. I want 4 to the x to intersect with 1 over 2 to the x plus 3. So I'm just going to equate them. The idea over here is, since the calculator is not allowed, you have to make sure that you make the bases equal of both the sides if possible, so that it will be easy for you to solve. I think I can do that. 4 to the x is equal to, can I write 4 to the x as 2 square to the x? Can I write 1 over 2 as 2 to the minus 1 to the x plus 3? And 2 to the 2 square to the x can be written as 2 to the 2x, and this can be written as 2 to the minus x minus 3, which means that 2x is equal to minus x minus 3, which means that adding x both the sides, 3x is equal to minus 3, which means that x is minus 1. So it has to be option C. That should be the answer. All right, I'm going to solve this one for you. This one looks a little interesting. Question 120 and then question 122 as well. I think that looks 123 actually. So 3 plus 2 times e to the minus x is equal to 11, which means that 2 times e to the minus x is 11 minus 3 is 8. Dividing both sides by 2, it's e to the minus x is 4. But honestly, guys, this here you cannot make the bases equal. So in such cases, since you need to bring x down, you need to take log with the same base as the base of the exponent on both the sides. In other words, take natural log on both the sides, which means that over on the left side, negative x is going to drop down and ln e is 1, and this is equal to ln 4, which means that x is minus ln 4, which, yes, fortunately is option C. And finally, question 123, we have this equal to 12. So 3 times 8 to the x is 12. Divide both sides by 3. So 8 to the x is 4, which means that now 8 and 4 cannot really be converted as a 1 of 1 to the 1 as a power uh, to give another one. But both can be converted to a third person or a third number that will be a power, that these will be a power of the same third number, which is 2. Because 2 cube is 8 and 2 square is 4, which means that 2 to the 3x is 2 square, which means that 3x is 2, which means that x is 2 over 3, which is option D. Okay, 3.1 periodic phenomena. Which the figure shows two full periods of a function, which of the following statements is true. They're asking what is a period and then something, what is f of 31, all right. I think finding period should not really be a problem because I can just see that one cycle is this much, right? And then obviously this is the next cycle. So it starts from 1, ends at 6, how much it has traveled, 5 units. So the period has to be 5, of course. So that's that thing. And they're asking what is f of 31. Now, for f of 31, you have to be a little, well, obviously you do not really see 31 on this, on this graph, right? So that's why the catch over here is we know that after every 5 units, the function is going to repeat itself. So f of 31 is going to be actually same as f of 31 minus 5, which is f of 26, will also be same as f of 26 minus 5, which is f of 21, and so on and so forth. So how many more 5s can I take out from here without making it negative? Because I don't really see any negative on my graph, right? So I think I can take 4 5s, if you understand. So basically I can do minus 5, minus 5, minus 5, minus 5, which is 21 minus 20, and 21 minus 20 is just 1. So f of 31 is just same as f of 1, which is just 1. Another way of thinking about this is, since we are interested in what is the leftover, you can also divide 31 by the period and think about the remainder. So when 31 is divided by 5, the quotient is 6 and the remainder is 1. So you are again looking for f of 1. So that's another way to think about it. Either way, the answer has to be option A. Right. Again, we are given two full periods and we have to find what is the period of G. So I think isn't that the same thing? It starts from here, goes this, and this. This should be my period because then it is just another cycle of it, which just looks like the yellow one. It starts from 0, goes all the way to 7. So the period must be 7 over here. And what is the value of G of 32? Let's apply our the remainder thing now. 32 divided by 7 is going to be 7 times 4 is 28. So I'm left with a remainder of 4. So this is going to be same as G of 4. And what is G of 4, guys? Well, that's 4. So answer has to be option D over here. Oh, we have one more. Which of the following in which of the following intervals is G decreasing in nature? This is again, guys, coming from the concept that we learned in unit 1, literally I think 1.2. Decreasing means obviously descending in nature. This is constant, this is increasing, this is decreasing, and likewise this is also decreasing. But again, you must have noticed that they have some intervals that we do not see anywhere on the curve. So again, the idea is same as most likely we want to get 4 to 6 as my answer. So there should be a difference of 2 units anyway, which is in all the options. But I'm interested that which one, when divided by 7, will leave a remainder of 4. I think 74, because 74 divided by 7 is 7 times 10 is 70, and you leave a remainder of 4, which is, this point will then be same as 4. And likewise, 76 divided by 7 will leave a remainder of 6. As isn't this something that I want? Because I already highlighted that thing on the curve. So that should be option C as my answer. Right, guys? Okay. Jumping on to this question over here, we are given a unit circle and they are interested, they have given the value sorry, the coordinates of the point P and of the point R as well. So of the point P, the coordinates are x comma y. For R, it is negative x comma y. They are saying what is tan of theta. Okay, I don't really understand what is the point of giving the coordinates of R, because R has nothing to do with theta, isn't it? Or are they trying to trick us? I think I don't really know what is the point of giving R, because I'm just interested in tan theta, and tan theta is the terminal ray for the theta is P, and tan is what, guys? Y coordinate over the x coordinate. So literally the only option matching with this y coordinate over this x coordinate is option A, because it is the ratio of vertical displacement, which makes sense because vertical displacement is the opposite to the horizontal displacement, which is the adjacent. And isn't that the definition of tan theta, guys? It's opposite over adjacent, right? So yeah, that should be the answer. Okay, here they're asking that figure shows this thing measured in theta. The coordinates of P are given. What is the value of tan of theta? So they are relying on us to find the coordinates of R first, and we can see that it is at the same height. So the y coordinate is not really going to change, and the x coordinate is just exactly on the other side. So if this is 4, this has to be negative 4. What are they asking? Tan theta. So tan theta is once again a y coordinate over the x coordinate. So that's going to be 3 over negative 4, and 3 over negative 4 is just same as negative 3 over 4, right? So it has to be option A. Okay. This is also something about, I see. Here we are given that the length of the arc PQ is 15 units. So this thing is 15 units, right? This thing is 15 units. Which of the following gives the distance of the point Q from the x-axis? Okay. The distance of Q from the x-axis is nothing but this value, or the y coordinate of the Q, right? Okay. We also know that the radius is 13. It's hidden over here. So that's radius. That radius is 13, which means that 13 should be somewhere over here. Okay. All right, guys. So don't you think that if I can just get this theta, I can use the sine theta will be equal to opposite over hypotenuse, and my answer will be 13 times sine of theta. That's my answer, right? But I do not have the theta. And that's where I think you might be knowing this, because this is used in SAT as well. The arc length formula. If you look at this pizza slice structure, which is basically a sector, for this sector, that we have a formula for the arc length, which is theta multiplied by r, where theta should be in radians. So arc length is given as 15, theta I do not know, and the radius is 13. So if I divide both sides by 13, then 15 over 13 is going to be the theta, and this theta I'm gonna sub in over here. So y comes out as 13 sine of theta, where theta is 15 over 13. So 13 sine, 15 over 13, that is option D. All right, I think this is a similar question, that the length of the arc PQ is 3 units, and what is the distance of the point Q from the y-axis? There's literally no difference here. This radius is 4, so this over here is 4. I know that the arc length L is given by theta multiplied by the radius. The arc length L is 3, theta I do not know, the radius is 4, so 3 over 4 is the angle. And once again, they need the distance of the Q. Okay, this time they need the distance of the Q from the y-axis. Apparently, that's the only difference. So they need this x. If this is x, then this is also x. So the only difference is and by the way, guys, this vertical height is not 3, just to be clear. The arc length is 3, this guy. So I think cos is going to help us. So cos theta is adjacent over hypotenuse. So 4 cos theta is going to be x. So x is going to be 4 cosine of 3 over 4. 4 cosine of 3 over 4, which is, there you go. Option C makes absolute sense. Okay. Over here, we are solving for the trig functions, guys. Now, the function is um, solve for trig equations now. But remember that the restriction is 0 to 2 pi. So guys, these questions definitely demand a really strong memory of the unit circle. If you don't remember, either keep a copy of it with you, or my recommendation, memorize it before trying these questions, because if you don't remember the unit circle, you might struggle with my explanations as well. Okay, what are the values of theta for which f theta is -3? So f theta is 6 cosine theta, and that is equal to -3, which means that cosine theta is dividing both sides by 6, so that's -1/2. And where is cosine negative? Cosine is negative in quadrant 2 and quadrant 3. What is the reference angle for 1/2? 1/2 is 60 degrees, or pi/3. So what is the quadrant 2 equivalent of pi/3? Once again, this is all unit circle. I'm just doing it in a different way, but if you approach, usually students approach this with a unit circle method, so feel free to use that. If this is pi/3, then this is going to be 2 pi/3, and this is going to be 4 pi/3. How I got these numbers? I usually find a reference angle. Reference angle is by disregarding the negative sign and just solving for cos theta equal to 1/2, which I did. So I got pi/3, and I know that cos is negative in quadrant 2 and quadrant 3. And if I want to move a quadrant 1 angle in quadrant 2, I will do pi minus that angle, and in quadrant 3 I will do pi plus that angle. So that gives me 2 pi/3 and 4 pi/3, which is option D, right? Okay. Likewise over here, g theta is √2, which means that 2 sine theta is square root of 2, which means that sine theta is square root 2/2. Sine is positive in quadrant 1 and quadrant 2. The reference of √2/2 as in one of the angle is the actual answer as well, which is pi/4. And to convert this quadrant 1 angle in quadrant 2, you do pi minus that angle, which is going to be 3 pi/4. So that's pi/4 and 3 pi/4. It should be option A. Likewise, over here we have 2 minus sine theta is equal to 2. 2 and 2 is gone from both the sides, so negative sine theta is equal to 0, which means that sine theta is 0. And sine is 0 whenever on the x-axis, basically. So x-axis is what? 0. If you remember unit circle, it's just as simple as x-axis is basically 0, pi, 2 pi, 3 pi, 4 pi, and so on. Since we only need between 0 and 2 pi not included, so the answer is 0 and pi, which is option C. And then we are given that the function k is given by this. What are all values of theta for which k theta is 2? So this means that 1 minus cos theta should be equal to 2, which means that negative cos theta is 1, which means that cos theta is -1. So cos theta is -1 wherever the y coordinate is the x coordinate is -1. In other words, we are talking about negative x-axis right over here, this point, and this angle is, of course, pi. So cos pi is -1, we know that. So I'm just going to mark option A. 26 should be A. Okay. Okay, this is all about synthesizing the trig functions. So we are given a model, a graph, and we need to figure out what is A and D. A and D are honestly the easiest, and in fact, B is also the easiest. B as in the guy that is dependent on the period. So these guys are pretty easy to find. But yeah, we'll do some horizontal shifting things as well. Those are a little tricky. But anyway, for D, the formula is maximum plus minimum over 2. The maximum y value is, well, just 0. And the minimum y value is -4 over 2. So -4 over 2 is -2. That's the value of D. So it has to be either this or this. And then the absolute value of A, because we don't really, A depends on the sign of A depends on the orientation as well. So I cannot rush it to just call it A. But yeah, absolute value of A I can definitely figure out, because that's just maximum minus minimum over 2. So A is going to be maximum minus minimum over 2. Maximum is 0, minimum is -4 over 2, so that's going to be 2. So that's absolute value of A. But now the question is whether that's -2 or 2. So that depends on the parent, as in this is a parent of sine. And sine parent has a tendency to start from the midline and go up, which is also being followed over here. So had it started from, still from the midline, but started going down like this. So obviously you know that this is a reflection about the x-axis, and reflection about the x-axis would make A negative. And that then I would have picked option A. But right now there is no fancy stuff going on here. It's just option C, because the blue thing is no longer, well, here. So it's just option C. Yeah, makes sense. Okay. Once again, okay, this time I need to find B. I'm going to find B first, because that's dependent on the period. So let's figure out the period first. The period is going to be, it starts from 0, and this is where it's one cycle complete. So period is definitely going to be pi. So the value of B is going to be 2 pi over the period, which is 2 pi over pi, which is just going to be 2. So it has to be either C or D. Now, absolute value of A, here, fortunately, I don't have to worry about the sign, because they are just interested in the number. It's not a game of signs. So absolute value of A is maximum, which is 4, minus minimum, which is -8, over 2. So that's 12 over 2. 12 over 2 is 6. It has to be option C. I hope you understand. Okay. In this case, well, isn't that pretty straightforward? They're asking period and amplitude. So the period is, let's say it starts from here and goes all the way till here to complete one cycle. So that's the difference between -2 and 2. We have to travel, what, 4 units? So the period is 4. And then the amplitude is just maximum minus minimum over 2. Maximum is 3, minimum is -1. So 3 minus -1 over 2 is 2. So that has to be option C. That's a pretty straightforward question. Now that's what I'm talking about. And these questions are slightly confusing, because if you notice that this is not really a game of finding B or D, because D is literally same in all the options. B is same in all the options, I mean, except this one. So most of the options, they are trying to test some other skills over here. So let's find B. I'm pretty sure it will be 2, but let's do that officially. So we can see that the period goes from 0 to pi. So the value of B is 2 pi over the period, which is pi. So it is going to be 2. So that's 2 right over here. Okay. So it cannot be A. Now the question is, you should know that one trig function can be written in various sinusoidal forms. And just to be clear, sinusoidal can be sine or cosine, anything. If you notice that all these are cosine, now assume that this is correct. So see if this is adding up with the equation or not, because they are asking me to start pi over 2 units to the right, which is this point. So if this is really the starting point, or the horizontal translation, how can it be a positive 2? Because isn't that behaving exactly opposite to the parent? Parent starts from maximum. This guy is starting from the minimum. So there has to be a negative over here, which is not. So this is gone. Now this option wants to start from pi. Pi is right here. So this is just behaving like a normal parent. So why is there a negative sign over here? It should have been 2. So this is gone. 3 pi over 2 is right here, and this is starting from the minimum, and minimum is going to be negative 2. Yes, this is definitely matching with the logic. So that's how you do such questions. You actually reverse engineer from the options, because you cannot reach any one option because you don't really know. There are various ways, so you have to reverse engineer, see if the options are making sense, and then eliminate. Okay, feel free to try this on your own, guys. Again, the fight is definitely between B, C, and D, but I will just find this value over here. So the period it starts from here and completes one cycle here. So that's pi over 2. So that's going to be 2 pi over 2, which is going to be 4. So it cannot be option A. Now, assuming this is the correct choice, so, and remember all these are sine, so sine starts from midline. So this one says that I should start from pi over 4, there you go. And I should, and from after pi over 4, it is going down. So down means it should be a negative A value, which is, well, indeed it is negative. So B is the correct choice. But I can obviously tell you why C and D are wrong, just to be clear. This one is saying that I should start from pi over 2. There you go. And I should be negative. Well, no, that's not correct, because you should be positive. You are just going up, just like a parent. This one says I should start from 3 pi over 4. Okay, I won't mind. And I should be positive. Nope, you cannot be positive. You have to be negative, because you are now going down, which is opposite, reflected compared to the parent. So C and D are wrong. Okay. Which of the following best describes the behavior of g over the interval of 0 to pi over 2? Okay, I think unit 1 coming back. Clearly this is descending, so this is decreasing. And increasing rate, decreasing rate is a fancy way of asking concavity. Clearly this is smiling in nature, and a smiling means increasing rate. So it has to be option C. I hope you understand that. Okay. Which of the following best describe? Okay, I need to refer to the same figure. Between pi over 2 to pi. So pi over 2 to pi, the function is definitely negative, because it is below the x-axis. And is that increasing or decreasing? I think increasing, because it just keeps, ascending with time. So that's pretty straightforward. The answer has to be option C. And finally, we have to figure out which of the following best describes how the rate of change of g is changing over the, be careful with the wording. They're asking how the ROC is changing. Change of ROC means they are talking about concavity between pi to 3 pi over 2. And pi to 3 pi over 2 is frowning in nature. So frowning in nature means it is concave down. And concave down means ROC is decreasing. So it has to be either option C or option D. The reason is because it is concave down, not because it is concave up. It has to be option D. Oh my god, we have one more. Which of the following describes ROC on 3 pi over 2 to 2 pi? So 3 pi on, what are the options? Okay, positive and, okay. So 3 pi over 2 to 2 pi, the function is decreasing. Function is decreasing means ROC is negative. And 3 pi over 2 pi function is concave down, so ROC is also decreasing. So ROC is negative as well as ROC is decreasing, because the function is decreasing and the function is concave down. So that should be our answer, if it makes sense. Option D. All right, guys, I hope you are liking this video so far. If you are, please like and subscribe, share it with your friends, and if you need private tutoring, feel free to reach out. Right, this one is again, I think, asking the same thing, then the rate of change of h. So all these questions are literally the same thing. So I'm just gonna skip these. I'm pretty sure you can handle this. Okay, guys, this function talks about if we are given function, then how will the graph look like from 0 to 4 pi. Okay, right off the bat, I know that it starts from x equal to, I mean, the behavior starts from x equal to 0 because there is no horizontal, translation. It goes down after starting from midline because there is a negative sign sitting right here. So it automatically eliminates option A because this is going up. Next, I want to find the period. So the period is going to be 2 pi over b, and b is 2. So it has to be, the period has to be pi. So how can these two be the answer? Because in these two, if you see carefully, for option C, the period is, yeah, I mean, it is 2 pi, right? Because it's going like this. This is the period, which is 2 pi. And here, even worse, 4 pi. I don't really need that. I need option B because this is clearly a period of 2 pi. So just by finding that much, I can eliminate the other options and it has to be option B. Okay. Let g be the function given by cos x. The function h has the same period as g. The amplitude of h is twice the amplitude of g. Which of the following defines h in terms of g? Okay, what is the period of this guy? It's just 2 pi, right? Because that's just a parent. So obviously I cannot afford to play around with the x, because if you do a horizontal dilation, it will change the period from 2 pi. So I cannot afford these two. That's definitely gone. And the amplitude is just double, right? Double of g. So you have to obviously multiply a 2 out on the front. So it has to be option B, clearly. All right, guys, moving on to tan functions, tangent function, not the tangent of the line, the tan theta guy. If this function, which of the following is the vertical asymptote, remember that, remember guys, for VA, you want the inside guy, whatever the inside guy is. I always think in terms of whatever is inside because the inside thing can change. So I know that inside thing has to be an odd multiple of pi over 2. So odd multiple of pi over 2 is one way to think about it, but I think as per the options, I should not tell you that. I should tell you that the for the parent tan, um, the asymptotes are at, for example, pi over 2, negative pi over 2, and so on, right? For the parent tan. So if you want to generalize this thing, and so remember that the VA just depends on the guy that is sitting inside, and literally there is no change for this x. So all I have to do is take any pi, any of these, let's call it pi over 2 because I see only positive values here, and add the period, the odd multiples of period. The period is pi for the tan, and k is the what do you call it as, your integer. So for example, if you put k as -1, you are just going to get negative pi over 2 here. So this is the generalized way that it should be. The inside guy should be pi over 2 plus n pi. So in this case, it is pretty straightforward. But for example, over here, I will say inside guy is equal to pi over 2 plus k pi or pi k. So, but in this case, I will multiply everything by 2. So 2 times, remember that 2 should be distributed to everything. So 2 times pi over 2 is pi, and this will be 2 pi k over here. That's the value of x, so which has to be option C. All right, we have 2 more questions. I think I'm going to do the same approach here, that the inside guy should be equal to pi over 2 plus pi k. In this case, if you divide both sides by pi, then boom, 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 I'm left with x is equal to 1 over 2 plus, well, k. That's pretty neat. That has to be C. And likewise over here, x minus pi should be equal to pi over 2 plus k pi or pi k. Add pi both the sides, so it will become pi plus pi over 2 plus k pi. Now this is a little confusing. In fact, some of my students struggled while solving this question, because what they will do is they will add pi and 3 pi over 2 and say 3 pi over 2 plus k pi, but obviously they do not see this anywhere in the options. It's not like this is wrong. It is just that this is not in the options. So if this is not in the options, then you have to make sure to manipulate this in in some other way. So if you are the way we can manipulate this is, look at this pi and k pi. If you literally add pi and k pi, what do you get? You will get pi over 2 plus pi plus k pi, right? And what is pi plus k pi? You take pi as a factor and you're left with 1 plus k. Okay, well, x is an integer. So 1 plus k will also be an integer. So rather than writing 1 plus k, can't I just write it again as some integer k? If you're confused that how can 1 plus k become k, you know what? You can take the initial integer as some other integer. Let's say n. So you keep on taking this as n. This is n. This is n over here. This is n. Now can I take 1 plus n as k? Because 1 plus n is an integer and k is also an integer. And this is matching with option A. So yes, the options, the manipulation of the options was, of course, a little bit, um, different from what we thought. So again, nothing wrong with this, unfortunately, but that is not in the options. So they are tricking us with the options here. Okay, coming back to the graph section now. This is the tan. So for those guys, you have to know the parent functions very well if you want to answer these fluently. Okay, I know that it cannot be negative. This cannot be negative because parent tan looks like this. So there is no reflection of any kind, right? In this function, we can see there is no reflection of any kind. So I won't really pick any of the negative a's thing. And the period, as we can see, is from negative 2 pi to 2 pi. So that's 4 pi. So the value of b, now be careful, the value of b is not 2 pi over period. That's the sinusoidal thing. For tan, you do pi over the period. So pi over period is 4 pi. That's just going to be 1 over 4. Option D is the perfect choice, guys. I hope you agree with me. This one, yes, you are right. Yes, there is a reflection. So yes, you are going to rule out C and D because clearly this is reflected, keeping the parent in mind. And once again, this is negative 4 pi, negative 4 pi. So the period is going to be 8 pi. So the value of b is going to be pi over 8 pi. Pi over 8 pi is 1 over 8. So there you go. Option A is the best choice over here, guys. Right, this is about transformations. I think it should be easy if you remember the rules of transformation. F is mapped to the graph of g in the same xy plane by the horizontal translation of f by pi over 2 units to the right. So whenever we go pi over 2 units or whenever we go right, it is counterintuitive. We replace that x by x minus that value. And remember, they are obviously you can rule out C and D, but students usually confuse options A and B because they think that we can just subtract 4x and 4x minus pi over 2. But remember, only and only x should be manipulated, not 4x, which means that 4 still sits outside. That guy is a spectator, and the x is replaced by x minus pi over 2, which makes option B as the best choice and not A. A is wrong. All right, here we are supposed to do a change in the edge and make it k by doing a horizontal dilation by a factor of 5. Horizontal dilation by a factor of 5 means it is a stretch. And if you remember, in horizontal world, it is counterintuitive. So although it is a stretch, but x should be replaced by x over 5 and not 5x. So it will be 2x over 5, right? Which looks like option D. All right, guys, starting with inverse trig now. They are asking that if the function is sine inverse x, then what input value of f will yield an output value that is same as cos inverse root 2 over 2. Once again, guys, it's really important to understand the range of these guys as an arc cos, arc sine, arc cos, and arc tan. I'm just going to take a minute and do that. If you're already aware of it, please feel free to skip this portion of the video. The domain of these guys is -1 to 1, -1 to 1, and this guy is, well, pretty versatile, all real numbers. Range is -pi over 2 to pi over 2. This is parentheses -pi over 2 to pi over 2, and this is bracket 0 to pi. Okay. Now, I'm saying all this because if you are thinking about cos inverse root 2 over 2, you might think that cos is positive in quadrant 1 and quadrant 4, and then you might think that there are two possibilities. But no, quadrant 4 is not possible because that's not literally even in the range of cos inverse, right? So that's why you only return a quadrant 1 angle, which is pi over 4. And they are saying that what input value will yield. I want arc sine to be same as pi over 4. So think about where is sine inverse x pi over 4. At what x will sine inverse return an angle of pi over 4? Well, another way to think about this is sine of pi over 4 is what? It's root 2 over 2. So this means that sine inverse root 2 over 2, because this is inverse, right? X becomes y and y becomes x. So if you plug in sine inverse root 2 over 2, it will return an angle, and that angle is going to be pi over 4. So it has to be option D. Likewise, they're saying that what input value in the domain of G will result in an output value of pi over 2. So I want 2 cos inverse root 3x to be equal to pi over 2, which means that if I divide both sides by 2, I want cos inverse root 3x as pi over 4, which means that this guy again should be root 2 over 2. Haven't we seen this already? So the inside guy, which is root of 3x, should be root 2 over 2. I'm going to square both the sides. I need more space, of course. Well, I don't have one, but let's continue here. Squaring both the sides will make root 3x as 3x, root 2 as 2, and 2 square is 4, which means that 3x is 1 over 2, and divide both sides by 3, I have x as 1 over 6. So it has to be option C, I think. Yeah. Right. Here we need to solve trig equations. Pretty important, guys. Question number well, 85, where we are talking about this. Here I've seen students making one mistake, that when they see cos square theta is equal to negative cos theta, they take away one cos theta or divide both sides by cos theta. It will result in root loss, guys. So don't do that. A good way to do this question without losing anything is to add cos theta both the sides, and then take cos as a factor. So I'm left with cos theta times cos theta plus 1 is equal to 0, which means that either cos theta is 0 or cos theta plus 1 is 0. And just like a zero product property. Cos is 0 whenever angle is pi over 2 or 3 pi over 2 from unit circle. And from here, cos is -1 whenever angle is, I think, pi. So option D makes perfect sense. Okay, over here we are given this. So I'm going to isolate sine squared theta by dividing both sides by 2. So that's going to look like 3 over 4. I'm going to take square root on both the sides. So make sure you have the plus and minus, so plus and minus root 3 over 2. So this will have two sets. Sine theta is root 3 over 2 and sine theta is negative root 3 over 2. And honestly, this is going to give answers in all the four quadrants, because sine can be positive in quadrant 1 and quadrant 2. Quadrant 1 is pi over 3. Pi over 3. So pi over 3 is going to be one answer, and its equivalent quadrant 2 is 2 pi over 3. Once again, guys, I am just using unit circle. And this is going to be 4 pi over 3 and 5 pi over 3. So it has to be option D. Makes best sense. Okay, this one is, I think, pretty straightforward. We are just looking for the cos theta is root 3 over 2 over here. So, cos theta is root 3 over 2 means that this is in quadrant 1 and quadrant 4. Quadrant 1 is pi over 6, and its quadrant 4 is 11 pi over 6, which looks like option B. This over here, by dividing both sides by negative 2, I have root 2 over negative 2, so which can be, you know that sine can be negative in quadrant 3 and quadrant 4. Its reference angle, root 2 over 2, is going to be pi over 4. So its equivalent quadrant 3 is going to be 5 pi over 4, because, pi plus pi over 4. And quadrant 4 will be 2 pi minus pi over 4. So, well, there you go. Pi plus pi over 4 is 5 pi over 4, and 2 pi minus pi over 4 is 7 pi over 4. It has to be option D. Over here, we are given that h is a function that is f plus g. So what are the roots or zeros in the interval? Okay. So cos square x plus cos x is equal to 0. Well, isn't that something that we already did? So cos is taken out and I'm left with cos plus 1 is equal to 0. I'm just going to scroll up because I have a very strong feeling that, yeah, there you go. The only difference is that theta x was theta. So answer is pi over 2 pi and 3 pi over 2. Pi over 2 pi, and there you go. Option C, guys. All right, the next one now, these are a little different because these are inequalities, right? So be careful now over here how to do it. We are looking for 2 sine theta is less than minus 1, which means that sine theta is less than negative 1 over 2. Now, a unit circle will be really helpful over here. And remember that sine belongs to what? X value or Y value? Yes, it belongs to Y value. So I'm looking for the Y values where it will be less than negative 1 half. Where is negative 1 half? Right here. Let's say this is negative 1 half. So I'm interested in the values that are less than negative half, which happens right here. And when is sine negative 1 half? In quadrant 3 and quadrant 4, of course. Its reference for sine theta equal to 1 over 2 is pi over 6. So its quadrant 3 angle will be pi plus pi over 6, which is going to be 5 pi over 6, which is right here. And this is going to be 2 pi minus pi over 6, which is 11 pi over 6, which is right here. And I very well know that my answer is the yellow guy, which is 5 pi over 6 to 7 pi over 6. Of course, yeah, guys, if you are seeing 5 here, it's not 5 because that should be 7, and this should also be 7. Yes, you are right. I am hallucinating, but now I'm not. And yes, you are right. Option B is the correct choice. 7 pi over 6 to 11 pi over 6. Okay, another inequality, guys. F should be greater than G. We can do that. We won't really mind. 2 cos x is greater than root 2. So cos x should be greater than root 2 over 2. Cos is what? Of course, the x coordinate. And root 2 over 2 is somewhere over here, because this is x equal to root 2 over 2. And I want it to be greater than that. So I'm looking for this region. What is this over here? Quadrant 1, where cos is root 2 over 2. You agree that it is pi over 4. Then this will be, I think, 7 pi over 4, guys, right? So this is 7 pi over 4. So obviously the Here we need to break in two portions because we always start marking our inequality from 0. So I'm going to say that it is from 0 to pi over 4. That's the first interval. And then 7 pi over 4 to 2 pi, because when I end from, end my, circle or reading my circle, I will go from 7 pi over 4 to 2 pi, which I think option D makes sense. So yeah, it should be option D over here. Okay. This is a secant question, so now I have to find that where are the x coordinates of the point of intersection. So it's basically solving both the equations. So 5 plus root 3 secant of x should be equal to 3. So I'm going to subtract what? 5 both the sides. So this is going to look like -2. So secant x is -2 over root 3. You don't have to worry about secant because secant is the reciprocal of cos. So replace secant by cos and flip this guy. And now the same drill. Cos is negative in quadrant what? 2 and quadrant 3. The reference is pi over 6 because cos of pi over 6 is root 3 over 2. So its quadrant 2 equivalent is pi minus pi over 6, which is 5 pi over 6. And then quadrant 3 is 7 pi over 6. So it has to be option A. That's what we are talking about here. Okay. This is a similar question, guys. You need to find the points of intersection this times with cosecant. So you will do the same thing, take the reciprocal of cosecant as sine. So I'm going to skip this question. I'm just going to focus on VAs now because this is important. For the secant, the VAs are going to be all those points where remember the secant VAs are same as tan VAs, and cosecant VAs are same as cotangent VAs. We already did tan earlier. Just like tan, I'm just going to set the inside thing 1 over 3x to pi over 2 plus k pi. If I just take k as 0, because that's going to be the most basic sort of x, so it will give me pi over 2. So if I multiply both sides by 3, I have 3 pi over 2. So x is 3 pi over 2. Likewise here, this happens whenever the inside guy is equal to k pi. That's what is the condition for cotangent or cosecant. If I put k as 0, then I will just get x as 0, but I don't have that in the option. So I'm just going to put k as 1, which means that 4x is pi, which means that x is equal to pi over 4, which is going to be option B. Alright guys, now this is a portion that I've seen students struggle with. This is all about using identities, double angle identities, sum of difference identities, Pythagorean, reciprocal, and so on and so forth. So which one is equivalent to half of sine 2x? The moment I see sine 2x, the only and only identity that comes in my mind is double angle. So you should definitely memorize the identities before trying out these questions. In this case, I'm just going to replace sine 2x as 2 sine x cosine x. 2 is gone, and I'm just left with sine x times cosine x, which looks like option C. Okay, this might look horrific, but it's actually a really straightforward question because this matches with cos A, cos B, minus sine of, if you notice, same angle, A, sine B. Cos A cos B minus sine A sine B is cos of A plus B, not minus B. So the answer is cos of A plus B. And what is 5 pi over 11 plus 2 pi over 11? Is that 7 pi over 11, which looks like option B. Okay, likewise, this is sine A cos B minus cos A sine B, sine A cos B minus cos A sine B. This is sine of A minus B, not plus B. The cosine guy works opposite. So if there is a negative, cosine has a positive. But the sine guy just takes the same sign as it is in between. So sine of A minus B, which is going to be sine of 2 pi over 7 minus pi over 7, which is going to be sine of pi over 7, which is option C. I leave 114 and 115 in your safe hands. I'm pretty sure you can handle this. These two questions, if you want to confirm the answers, just post it in the comment section. I'll just look at it. Which of the following expressions equivalence? Okay, the moment I see cos square minus 1, it reminds me of Pythagorean identity because, you know, 1 sine square x plus cos square x is 1, if you remember. So sine square theta plus cos square theta is equal to 1, which means that cos square theta is or cos square theta minus 1 is minus sine square theta, because I subtracted 1 and I subtracted sine square theta. And isn't this what I have here? So replacing this with minus sine square theta, and replace secant is just as it is. And it looks like, yeah, well, none of the options are matching right now. How else can we manipulate? You know what? I'm just gonna rewrite this guy as sine over cos. Sorry, what am I saying? Secant as 1 over cos. Now, if we see carefully, can I write sine square theta as sine theta times sine theta? And can I write this cos? Well, just as cos. And if you notice carefully, sine over cos is tan. So it will become minus of tan theta, and sine theta is as it is. So yes, option B, we had needed, well, a little bit more manipulation, but yeah, that's how we do it. Cos x minus sin x whole square is cos square x plus sine square x minus 2 sine x cosine x. Cos square x plus sine square x is 1, and 2 sine x cos x, guys, we just used it. That's the reverse of the double angle of sine 2x. So I'm just going to replace that with sine 2x. So 1 minus sine 2x is option C. I think this should remind you of the same thing over here. 1 minus cos square x and sine square x minus 1, the Pythagorean identity. So we know that sine square x plus cos square x is 1. One way to manipulate this is sine square x will be 1 minus cos square x. So 1 minus cos square x is replaced by sine square x, which is over here. And this sine square x minus 1, this over here, we can rewrite it as cos square x is 1 minus, sorry, let's subtract 1 both the sides. So sine square x minus 1, and let's subtract cos square both the sides, so minus cos square x. So replace this by minus cos square x. And what is cos over sine? Cotangent. But obviously that's a square, so this will be minus of cotangent square x, which looks like option A. Okay, cos square x minus, so I think this one can be splitted in two pieces, if I'm not wrong. So can I rewrite this as cos square x, sorry, cosecant square x over cosecant square x minus 1 over cosecant square x? And cosecant square x over cosecant square x is 1. And what is the reciprocal of cosecant? Isn't that sine? So that's 1 minus sine square x. And wait a second, this guy looks familiar. Look at that. From here, 1 minus sine square x is just cosine square x, right? So this is cosine square x, which is option C. Okay, all right. This is again a double angle thing, guys. Cosecant x remains as it is, and sine 2x can be written as 2 sine x cosine x. Cosecant x is the reciprocal of sine, so 1 over sine and 2 and sine x, and then cosine of x. So these two are gone. So I'm left with 2 cosine of x, which is option C. This is also a double angle, but this is a double angle of cos. So I know cos has 3 double angle identities, sort of. It depends on, I'll write all 3 for you. Cos to theta can be written as cos square theta minus sine square theta. That's identity number 1. Identity number 2 is 2 cos square theta minus 1. and the third one is sine square, sorry, 1 minus 2 sine square theta. Now, you can ask me that which one do I use here? Well, that depends on the options. But yes, I think you can also tell that option A doesn't make, this one doesn't make sense because I don't see any options where cos square and sine square are in subtraction. This also doesn't make sense because if this was used, then sine square would have had a negative neighbor. So I think the middle one makes sense, and the answer looks like option C, because it will be 5 times 2 cos square theta minus 1, which is 10 cos square theta minus 5, which is option C. Yes, indeed. Okay, coming to the polar coordinates, so we have to find what are the values of x and y here. These are pretty straightforward, guys, all these three questions. I'm just going to do probably the last one, though, I mean 131 for you, because it's just literally a formula, and then that's about it. And the formula is x is r cosine theta and y is r sine theta. That's it. Just plug in the numbers blindly. So r is minus 4 and theta is negative pi over 2. I know that cos negative pi over 2 or cos of any pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, negative 5 pi over 2, etc. is 0. So x is 0. And y is r sine of negative pi over 2. I think you know that sine is an odd function. If you do not, then just again use the unit circle thing, and this was nothing but negative 1. So I'm getting 4, and 0 comma 4 looks like the best choice over here, or well, the correct choice over here. But yes, if you want to reverse engineer that what is r comma theta if x, y is given, the r has a formula of square root of x square plus y square. In this case, you can see that x is negative 2, so negative 2 square, and y is 0, so 0 square. So square root of 4 is just 2. But don't immediately rule out minus 2, because remember that a polar form, a polar coordinate can be written in an equivalent negative r as well. So don't really rule anything out. Yes, if there was a 3 or something, then you can rule out, but not right now. And what is the angle over here? Now you have to think that negative 2 comma 0 is on negative x-axis, which is obviously a pi angle in the polar world. So ideally speaking, the answer would have been or should have been 2 pi. But clearly that's not in the options. We have 2 zeros. So obviously that's not correct. Now, how can I convert this in a negative r? So the idea is you change the r to negative r and you change this angle with a multiple of odd multiple of pi. So for example, add a pi to it, or add a 3 pi, or add 5 pi, or add 7 pi, or subtract pi, 3 pi, 5 pi, 7 pi. And I think I can just see that if I just add a pi to this pi, there you go, 2 pi, which is definitely in the options. So it has to be option C. And finally, we have a complex number over here, and the complex number is to be written in rectangular form. So this is just a fancy way of seeing that what is r and what is theta. And that's it. You again use the same x is equal to r cos theta and y is equal to r sine theta over here. So that's going to look like x is equal to 4 cosine of negative 2 pi over 3. Which is going to be 4 times, I think, negative 1 over 2, which is going to be negative 2. And y is going to be r sine of negative 2 pi over 3, which is going to be, I think, negative 4 times negative root 3 over 2, which is going to be negative 2 root 3, which looks like option B.